3 minutes. That's roughly how long it took in September 2017 for a signal traveling at the speed of light to cross 930 million miles of space and confirm what everyone at NASA already suspected. Cassini was gone. But here's what almost nobody realized at the time. The spacecraft wasn't actually finished talking. Buried inside the data it had already sent home, spread across 20 years of images and measurements, were secrets that wouldn't get decoded for years. And in 2026, nearly a decade after Cassini burned up in Saturn's atmosphere, one of those secrets finally surfaced, overturning something scientists had believed about Saturn's largest moon for more than a decade. This is the story of Cassini's actual final images, what the spacecraft was looking at in its very last hours, and the genuinely shocking discovery its old data just delivered, years after the mission itself came to an end. Not a new photograph. Something arguably more significant. Proof that a spacecraft can keep changing our understanding of the solar system long after it stopped existing. Let's go back to where it all ended. Cassini launched on October 15, 1997, and spent 13 years orbiting Saturn after arriving in 2004. An extraordinary run that fundamentally rewrote what scientists understood about the entire Saturnian system. It discovered towering water ice geysers erupting from the south pole of the small moon Enceladus, revealed liquid methane lakes on the hazy moon Titan, and captured storms, rings, and moons in a level of detail no telescope on Earth could ever match. Along the way, it dropped the European Huygens probe onto Titan's surface in January 2005, the first and still only landing ever achieved anywhere in the outer solar system, and it snapped nearly 500,000 images over the course of its mission. By 2017, after roughly 7,000 days in space, Cassini was finally running low on fuel. Rather than risk an uncontrolled crash that might one day contaminate Enceladus or Titan, both considered potentially habitable, NASA made a deliberate choice. Send Cassini on one final, spectacular dive straight into Saturn itself. That plan became known as the Grand Finale. 22 increasingly close weekly passes through the narrow gap between Saturn and its rings, a region no spacecraft had ever dared fly through before, close enough that engineers genuinely worried a stray ring particle could disable the spacecraft entirely. And in its last few days, with its fuel nearly gone, Cassini turned its cameras toward the system it had spent over a decade getting to know, capturing one final set of farewell images before the plunge that would end everything. On September 13, 2017, Cassini's narrow-angle camera captured what mission scientists described at the time as a kind of visual scrapbook. A haunting portrait of Enceladus, sinking behind Saturn's rings, the same moon whose hidden ocean Cassini itself had helped discover years earlier. A last look at Titan, its thick orange haze glowing faintly against the darkness. A world Cassini had mapped more thoroughly than any moon beyond our own. Wide, detailed views of Saturn's rings, including one image capturing a small moonlet called Daphnis carving visible waves through the edge of the Keeler Gap, and another showing a lone propeller feature, a structure created by a tiny embedded moonlet trying, and failing, to carve a clean gap through the ring material. Mission scientist Linda Spilker at the time described the choice of targets plainly. The team was revisiting its favorite places in the Saturn system, one last time, for what she called their own version of a Cassini scrapbook. Images chosen not for their scientific urgency, but because the team simply wanted one final look at the places that had defined 13 years of their working lives. Then, on September 14, 2017, at 12:59 p.m. Pacific time, Cassini's cameras captured what would become its actual final image. A monochrome nighttime view of Saturn, lit only by sunlight reflecting off the planet's own rings, pointed directly at the exact patch of atmosphere where the spacecraft itself would plunge to its destruction roughly 16 hours later. It's a quiet, almost eerie photograph. Cassini, essentially taking a picture of its own grave hours before arriving there. The engineers back on Earth chose that final target deliberately, wanting one last visual record of the precise region of Saturn's atmosphere the spacecraft was about to become part of, data that would later help scientists characterize conditions at Cassini's actual resting place. At 4:55 a.m. Pacific time on September 15, 2017, Cassini's last signal reached Earth, roughly 83 minutes after the spacecraft had actually already been destroyed, torn apart by heat and pressure as it tore into Saturn's atmosphere at over 70,000 miles per hour. Cassini kept transmitting scientific data about that atmosphere for as long as it physically could, right up until the moment contact was lost for good, gathering readings on gas composition and structure that no instrument had ever collected this close to Saturn before, and quite possibly never will again. That was supposed to be the end of the story, and for most people watching the news that week, it was. Except it wasn't, not really. Because over the following years, scientists kept going back to Cassini's enormous data archive, held permanently in NASA's Planetary data system. and kept finding things the original mission team never had time to fully unpack, while the spacecraft was still alive and generating new data faster than anyone could process it. In 2023 alone, a separate reanalysis of Cassini's dust analyzer readings from Enceladus's plumes revealed the first confirmed detection of phosphorus, a building block essential for life inside an ocean beyond Earth, a finding that came 6 years after the spacecraft itself had already been destroyed. That pattern reached a genuinely startling peak in January 2026. A team of researchers reanalyzed radio tracking data Cassini had collected years earlier during multiple close flybys of Titan, using significantly improved processing techniques, including open-loop tracking data and phase compression methods that weren't fully available when the original data first came in. What they were measuring was subtle, tiny variations in Titan's gravitational field, caused by how the moon flexes and deforms as it orbits Saturn, a phenomenon called tidal dissipation. For years, based on earlier interpretations of similar Cassini data, many scientists believed Titan likely harbored a genuine subsurface ocean tucked beneath its icy crust. Similar to the ocean already confirmed inside Enceladus, it fit a broader, exciting pattern. Across the outer solar system, icy moon after icy moon turning out to be hiding liquid water underneath a frozen shell, a pattern that had genuinely reshaped how planetary scientists thought about where life might realistically be found beyond Earth. The new 2026 analysis told a very different story. By measuring what's called Titan's tidal love number, essentially how strongly the moon responds to gravitational tugging with each orbit, and calculating something known as its tidal quality factor, the team found a remarkably low value, roughly 5, compared to a solid, rocky world like Earth, which sits closer to 300. A low tidal quality factor like that indicates strong internal energy dissipation, deep, ongoing flexing, and friction happening inside the moon itself. And crucially, the specific pattern that dissipation follows is much more consistent with a moon that lacks a liquid subsurface ocean entirely, one where that flexing energy is instead being absorbed and dissipated through Titan's solid interior directly, rather than sloshing through a hidden layer of liquid water the way it does on Enceladus, and likely Jupiter's moon Europa. In plain terms, after years of assuming Titan was likely another hidden ocean world, quietly waiting to be confirmed, this new analysis of old Cassini data suggests it might not have one at all. Researchers describe the finding as consistent with independent evidence from a separate recent analysis of Titan's spin state, meaning this isn't an isolated result from one data set alone, but a conclusion multiple independent lines of evidence now appear to support. That's not a small correction. Titan had spent over a decade sitting on lists of the solar system's most promising places to search for life beyond Earth, largely because of that assumed ocean. This finding doesn't erase everything interesting about Titan. It still has liquid methane lakes, a thick nitrogen atmosphere, and genuinely alien chemistry, unlike anywhere else in the solar system. But it does mean the specific hidden ocean storyline scientists had been building around it for years may simply be wrong. It's a genuine reminder that even a well-established scientific narrative, repeated in documentaries and textbooks for years, can quietly shift the moment somebody finds a better way to read the same underlying data. And Titan wasn't the only surprise Cassini's old data delivered in 2026. Just weeks later, in February, a separate team studying archived measurements from 4 different Cassini instruments spanning 13 years of flybys discovered that Saturn's moon, Enceladus, interacts with Saturn's magnetic field far more powerfully than anyone had previously realized. An electromagnetic connection stretching more than 500,000 kilometers, over 2,000 times the moon's own radius. Researchers described finding a complex web of reflected electromagnetic waves rippling outward from Enceladus, not just along its orbital path, but shooting towards Saturn's north and south poles as well, evidence that this small, icy moon is actively pumping measurable energy into the environment of an entire gas giant. Scientists working on the study noted the waves weren't simply large and uniform either. Under the influence of turbulence, they broke apart into fine, complex filaments, a level of structural detail nobody had previously had the tools to detect across 36 separate flybys recorded over more than a decade of Cassini's working life. Neither of these findings came from new images. Neither came from a spacecraft still operating. Both came from scientists returning years later to data Cassini had already quietly sent home, sitting untouched in an archive, until better tools and more time finally let researchers see what was actually hiding inside it. That's really the deeper story behind Cassini's final images and everything that's followed them. The photographs themselves, the eclipsed Enceladus, the last look at Titan, that haunting final view of Saturn's nightside, were never really the end of what the mission had to say. They were simply the last visual chapter of something scientists are, in a very real sense, still reading. Cassini generated more data than any planetary mission in history, so much that the tools needed to properly analyze all of it are in places only now catching up nearly 9 years after the spacecraft itself stopped existing. NASA's own planetary science decadal survey has since ranked a dedicated Enceladus orbiter mission as a top priority for the late 2030s, and the European Space Agency is separately scoping its own concept for a return mission to the Saturn system, both efforts shaped directly by exactly the kind of archived Cassini findings still surfacing today. So the next time someone tells you a mission ends the moment a spacecraft goes silent, remember what happened to Cassini. Its last picture was taken in September 2017. But some of its most significant discoveries, the ones genuinely reshaping how scientists think about entire worlds, are still arriving now, pulled quietly out of an archive. Most people forgot was still being read by researchers who were undergraduates when the spacecraft first launched. If you want to know what Cassini's old data reveals next, subscribe and turn on notifications. Because based on what's happened just this year alone, this spacecraft clearly isn't finished telling us what it saw.